The last thing we're going to talk about is how to classify triangles. So you're going to notice this works kind of the same way, except these are going to be triangles in these problems, all right? So you're going to kind of follow the same pattern, same steps as you did with quadrilaterals. So if I had to classify this triangle, and they gave me the coordinates, I'm going to start by graphing them. So A is at 0, 0. B is at 3, 3, 2, 3. And then C is at negative 3, 3. So 1, 2, 3, 1, 2, 3. So make sure you graph them correctly, because if not, then obviously you might classify it wrong. Okay, so this is A, this is B, this is C, and then I'm going to connect them. So it's a triangle. And again, you can kind of go off of looks a little bit. You don't want to go off of looks completely, because sometimes that could play with you. And so if I look at this, it kind of looks like these two sides are equal in length. And so I'm going to check those. And then from there, I'm going to have to look at the slopes, because if you have a right angle, you're going to have to say that, you know, it's a right triangle. Okay. So just like what we did with the quadrilaterals, you're going to start by finding the length of each side, which is like the distance. So this one's easy, so I'm actually going to start with that one. So BC, you can count. So that's 1, 2, 3, 4, 5, 6. So BC has a length of 6. So I'm going to go ahead and do that one. These two are a little harder because you have to make your right triangle. So if I find this one, my right triangle, that would be 3. That would be 3. So if I did it, it'd be 3 squared plus 3 squared equals C squared. And notice that's actually a similar equation to what we did in the other one. So when I solved this, it was 9 plus 9 equals C squared. And then we had 18. And then we had the square root. And so C was whatever the square root of 18 was, which ended up being 4.24. So the length of AB ends up being 4.24. All right, so now we do the same thing for CA. Make your right triangle, plug it in Pythagorean theorem. So if I make my right triangle, that would be 3. That would be 3. And notice it's the same equation. So my hunch that those two sides were equal was actually correct. Okay, so the first thing that I know about that triangle is that it has two equal sides. Now, pull out your little sheet and see what type of triangle has two equal sides, and you'll realize that makes this what's called an isosceles triangle. Okay, so that's one way of classifying it, is now I know that it is an isosceles triangle, but you have to make sure you have to classify it by the angles as well. And so the thing that we're going to practice checking is to see if it has a right angle. And so notice you can kind of look at it to see maybe where your right angle would be. And so like if I'm kind of looking at this, these angles look acute. They look pretty small. But this one, like if you kind of turn it sideways, it looks like it's a right angle. So I'm going to be paying attention real closely to that one, because it might be right, okay? Or it might be a right angle. So I'm going to find the slope of each line. So like if I start with AB, slope, remember, is rise over run. So if I had to go from here to here, I have to go down 3. So that's my rise part. So down 3 would be a negative 3. And then I have to go left 3. So that'd be a negative 3 on the bottom. So the slope would be 1. BC, well, that's a flat line. So if it's a flat line, the slope is 0. And then CA, to go from here to here, I have to go down 3 and right 3. So down 3 would be a negative 3. And then right 3 would be a positive 3. So that ends up being negative 1. Okay. So the two that I was wanting to check was AB and CA. Where those two come together, what kind of angle is this? So I'm going to look at those two slopes. I'm going to ask myself, are they negative reciprocals? Because remember, that would mean that they have to be perpendicular to have a 90-degree angle right there. So I'm going to take 1. I'm going to write it as a fraction. I'm going to flip it, which would be the same thing. And then I'm going to change the sign of it. Does that give me the other one? And notice it does, so that means that these two are negative reciprocals. So that means not only are the two sides equal, but they are perpendicular. They cross at a 90-degree angle. So then what kind of triangle is it? Well, we already discussed this isosceles, but it's also a right triangle. So you would say that this is a right isosceles triangle. Okay, so let's do one more and then you can work. All right, so start out by graphing it. So we got 0, -4. 1, 2, 3, 4. We got 0, -9. So 0, and then that was 4, 5, 6, 7, 8, 9. And then we have -2, -5. So -2, 1, 2, 3, 4, 5. All right, so this is a little triangle, which happens. So let's connect our points, and then let's figure out what's going on. So these questions are very specific. It says, determine if the triangle is scalene, which scalene, remember, means that none of the sides are equal, isosceles, or equilateral. Well, some of these we can cancel out just by kind of looking at it. Notice, equilateral means that all the sides are equal, and I can see that it's not going to be that. Okay, so I know that one's out. Well, isosceles would mean that 2 of the sides have to have an equal length. And so the only 2 sides that might have a close length would be this one and this one. So you can find the length of each side and do that. So this one has a length of 1, 2, 3, 4, 5. So that one has a length of 5. That one I'd have to do Pythagorean theorem with. So let's see, 1, 2, 3, 4. It'd be 4 squared plus... that was 2 squared equals c squared. I'm just going to solve that real quick and see if I get 5 out of it. So that's 16 plus 4 equals c squared. And then 16 plus 4 is 20. And so I get 20 equals c squared. And so from there you have to square root both sides. So c equals 4.47. And notice it's close. Like I said, it's going to be close, but it's not exactly 5. So these 2 are not the same length. And then that one's definitely not going to be the same length. So because none of the sides have the same length, then this one would be scalene. And so sometimes you may not have to find all of the lengths, but you need to make sure, because some of them could be close and you might be surprised. All right, so that's how you classify it, by the lengths. And then it says determine if the triangle is a right triangle. Well, that means you have to look at the slopes. And so if I look at this angle, that's not a right angle, because it has to be a right angle, it'd have to be like that, and that's not it. This one's definitely not a right angle. But that one looks potentially like a right angle. Like if you kind of turn it sideways, you can kind of see that it looks right. So this is the one that I want to check, okay? And I didn't label this, so let me label it. So this one was A, this one was B, and this one was C. So we're going to find just the slopes of AC and BC and compare them. So AC, I'm going to do the rise over run. So like if I go from C to A, I have to go up 1 and right 2. So that'd be, the slope would be 1 over 2. For CB, well, I have to go down 1, 2, 3, 4. So that'd be a -4 over, and then I have to go right 2. So it'd be -4 over 2, which is -2. So check those slopes. Are they flipped and the signs change? So if I take this one and I flip it, it'd be 2 over 1. And then if I change the sign, I get -2 over 1, which is -2. So that means that they are flipped and the signs are changed from one another. So that means that these 2 are perpendicular because they have negative reciprocal slopes. So that would have a right angle in it. Okay. So determine if the triangle has a right angle or is a right triangle. And yes, and this would be your proof. And so you'd say yes. And then if they asked you to classify it, you would put those 2 things together. So you would classify this triangle as a right scalene triangle. So you have to check the lengths of the sides and the slopes.